Law number 6. We got 2 laws left. Law number 6, when we're dealing with exponents, talks about what happens when you have an exponent of 0. We have explored this in some of our classes already. We have kind of discovered what this means when you have an exponent of 0. But just to make it official, if a power has an exponent of 0 on it, that entire power is simply equal to 1. A simple algebraic way, obviously, to represent that looks like this. So, if we want to understand why this is the case, I'll dedicate just a few seconds to that here. If, for example, I give you, and we don't need to write this down necessarily, but if I, for example, give you 4 to the third over 4 to the third, just random 2 powers that are the same, of course, that would equal to be 64 over 64. And any time you have the same thing on the top and the bottom of a fraction, that's considered one whole. If we were to apply the laws of exponents to this guy, we would get 4 to the power of 3 minus 3. Keeping the base of 4, subtracting the exponents, well, that'd be 4 to the power of 0. That is also then equal to 1 because this guy, originally, this original fraction was equal to 1. Okay? So that's kind of how this works, but let's go ahead and try and practice some examples, seeing how this plays out, even though we already have in several cases. Here's one example, 3 squared times a to the 7th over 3 a to the 7th. Of course, this is greatly simplified from our last set of examples from our previous law. You simply have a quotient of powers here. When you divide the 3 squared by the 3 to the first, you get 3 to the first. And then a to the 7th over a to the 7th, when you subtract those exponents on the a's, you get a to the power of 0. And we know then that is the same as saying 3 times 1, which means we can really just write 3. Okay? This guy essentially just becomes a 1. Next question, same idea here. When we have b to the 4th divided by b squared in this first fraction, we get b to the 2nd power again. The exponents on the c's come out to be a 1. And again, this d to the power of 0, that entire power, this whole thing, becomes just a 1. Okay? And when you multiply b squared times c to the 1st by 1, you still get b squared times c to the 1st. And so we can represent our answer that way. Be careful that you only take the actual power that has an exponent of 0. Make only that equal to 1. Some people, in this case, for example, in my previous example here, some people may say, oh, I see an exponent of 0, therefore the entire answer must just be equal to 1. Okay? But it's only the power that actually has the exponent of 0 on it. That's the a to the power of 0 there. That's what becomes a 1. Alright, here's a good one. Go ahead and simplify that. And as I let the shock and awe of this massive question settle down here, hopefully you are starting to think about the fact that this exponent of 0 this power of 0 is going to make its entire power that it's applied to, which is this thing, it's going to make the whole thing equal to what? 1. So really, it doesn't matter what's happening inside here because it's all to the power of 0. The answer to this question is simply going to be 1. Okay, law number 7, last but not least, is what we do when we have a negative exponent, okay? And we have had negative exponents in this chapter already, which is fine, and we've just let them rest in our answers. But folks, from this point forward now, if you have a power with a negative exponent, we're going to move it across the line to make it a positive exponent. And so that you can understand what I mean by this, I'm going to show a little magic trick to wrap up this chapter on exponents. I've been practicing a lot for this. I'm quite excited to show you. Okay. I'm going to have an expression like this. It says a to the power of negative 4. And as we've said here now, we cannot just leave this as our expression. We must make this exponent positive. So as the law states, we're going to move the power across the line, which simply means we're going to move it from a numerator position across the line down to a denominator position. Okay? And so what that looks like is this. I'm going to take my magical red curtain over here, okay? And I'm going to move the a to the negative 4th power, that whole power there, and I'm going to move it across the line. When I moved it across the line, the negative 4 became a positive 4 as it moved to the bottom there. And so now we are left with a 1 over a to the positive 4th power. Folks, that is the magic trick of the year. So let's just recap here. A to the power of negative 4 is equal to, and should be represented as, 1 over a to the positive 4th power. In case you are still stunned, I am going to do one more example like this, where instead of it being in the top, we're going to put the negative exponent in the bottom. You can't leave a negative exponent in your expression. So we're going to move the whole power, okay, the base and that negative exponent, we're going to move it across the line to the top. So we're moving it from down here up here, and voila, your new answer is 3 to the power of positive 2 over 1. Okay, again, quick recap. 1 was over 3 to the power of negative 2. That's just the same thing as 3 to the power of 2. You could say over 1 if you want. Okay, so let's see how this works with some examples for a moment. Let's say we are going to simplify this expression here, x to the 4th, y to the 3rd over x to the 6th times y. And that y has an exponent of 1. So in simplifying this, we're going to, of course, use the fact that the law that talks about what happens when you have a quotient of powers, and when you have a quotient of 2 powers that have the same base, you keep the base, you subtract the exponents, and you get x to the power of negative 2. Okay? Of course, you also get, let's just keep finishing it up here for a second, y to the 3rd divided by y to the 1st will give you y squared. But this cannot be your final answer anymore. We cannot leave the negative 2, the power of negative 2 up there. So we're going to take this power and move it from the numerator position down underneath to the denominator position. okay? And so, I guess just to kind of tie this back to the magic trick, if you notice there's that 1, of course, that's always in front of the variables, where it's going to stay up here, okay? It's also got the y squared that's going to remain on top to keep him company. But the x to the power of negative 2 is going to move across the line, and it will now be represented as x to the power of positive 2 down there. And that will be your final answer. You don't have to put the 1 there. You could write this answer without it. Okay? Don't underestimate this guy. This says 9 to the power of negative 2. That does not mean it's negative 81. Okay? You can't simplify 9 to the power of negative 2, as a matter of fact. You can't. You've got to make the exponent positive first. So we're going to take this expression and move it across the line. It's currently kind of above an understood 1. We're going to move it down underneath, so we'll say 1 over 9 to the power of positive 2. And then we can finish this one off